Hello. Today we are doing questions from electronics. Electronics questions, actually we get 3 questions in our MCQ paper. So we should always be prepared with electronics questions. So maybe you are not that good with electronics, but you have to practice electronic questions for the MCQ paper. You may not be ready for the essay paper, that's okay, but still try these type of questions. You can easily get these 3 marks for the MCQ paper. So I'll be giving you a couple of questions, try the questions, and then let's go through with the explanation. Right, first question will appear very soon. Try the question and go through with the explanation. Right. Alright, these are the very basic theories actually you should know when it comes to transistors. So this current through the transistor here we call IC, and current through this part is IE, and this is IB current. Right. So IE is equal to IC plus IB, should know that, and beta, the current gain, is equal to IC divided by IB. Right. So here actually this method, the method actually I am drawing is we call it common emitter configuration. So in lots of questions actually we are getting from common emitter mode, common emitter configuration. Right. These are the 2 things actually you should know. Other than that, VBE value, if it's made of silicon transistor, we take it as 0.7 volt, and germanium transistor we take it as 0.3 volt. And of course when it comes to the regions of transistors, if the transistor in cutoff region, we take VCE equal to the supply volt, and if it's in saturated region, VC equals 0, and in between any value we call it in active region. Right, these are the things actually you should know. Of course current flows from B to E in this transistor. It's NPN transistor, in PNP transistors, other way around. Right, these are the basic things actually you should know when it comes to transistor. Let's get into the question. I hope you have tried the question, and if you could get the answer, that's great. Right, so they are telling us there will be 20 milliamperes through this LED, that means to the diode, if 2 volt potential is between the diode. Right, and beta value is given. Of course you know what is beta. Beta means IC over IB is 110. They are telling the transistor in saturated mode. Right, saturated means VCE value, it has to be 0. So if the potential here is 0, then C, it also has to become 0. Then that means potential difference across from this 6 volt to C point C is 6 difference, and this LED is taking actually 2 volts. So remaining 4 volt will be in between this RC resistor. Right. So then what we have to do is we have to apply V equals IR for RC resistor. RC resistor. Let's apply V equals IR for RC resistor. Right. Potential difference across RC resistor, it's 4 volt now. Right, and the current, actually we know the current through the LED, yes, it's in series with RC, so the current will be same through the LED. So it's 20 milliamperes, 20 into 10 to the power minus 3, that into RC, that is answer. So let's subject RC 4 divided by 20 into 10 to the power minus 3. Right, so 0, 10 to the power minus 2, 400 divided by 2, it's 200 ohms, that is RC value. So if you could get the answer, that's great. Right. Moving into RB. So to find RB, actually same procedure, we need to find the current through RB. Actually now we know the potential difference across RB, here potential is 0. Right. So they are telling potential difference across VB is 0.7. So then the potential at point B here, base, it has to be 0.7. Right. So the potential difference across this RB resistor, it's 2 minus 0.7, it's 1.3. So let's apply V equals IR. The same thing for RB, right? So IB, that of course we don't know. IB current actually we don't know, but we know IC current, right? So IB equals, from this equation, it's IC divided by 100, right? So IC, where's IC? 20 milliamperes current through here. So it's 20 milliamperes, 20 into 10 to the power minus 3, right? Again, that divided by 100, so it has to be 10 to the power minus 5, right? That into RB. So we have RB now. Let's simplify it. Now 1.3 divided by 20 into 10 to the power minus 5. There's an easy method to simplify these type of questions. Actually, let's multiply this by 5 and this by 5. So it's 5 into 1.3, it's 6.5. 6, I hope you can see it. 6.5 divided by, let's write it here. 6.5 divided by 100 into 10 to the power minus 5. So it's 10 to the power minus 3, 6.5 thousand. So it's 6.5 kilo ohms, right? I hope you got the answer. Then you saw the method. If you couldn't, you saw the method. Try these type of questions. You should know the theories behind the question for sure, right? Let's move into the other question now. I hope you have tried the question, and if you could get the answer, that is great. That means you know theories, right? So let's get into the question now. So here they are giving us two types of transistors. Here we have JFET, junction field effect transistor, and here we have bipolar transistor, regular transistor. We normally know, right? We are supposed to know both actually. Anyway, so they are asking us to find the potential difference across drain and source. We call it VDS value, right? So when doing this question, actually we have to make couple of assumptions. One assumption I'm gonna make is that the potential difference they are giving us here is 0.7 volts. So I'm taking BE junction is forward bias. Then only we can see a current through IC and also through the drain and source, right? So ID current is possible only when the transistor in active region, right? So BE has to be forward bias. So I'm starting it from here, and also they are giving us another data, VGS equals minus 1.2 volt. So from this data also we have to get something. That means the potential, we know there's no current through, there's no IG current, right? So that means the potential here, it has to be 0. Then the potential difference VG minus Vs equals minus 1.2. That means the potential at S source, it has to be 1.2 volt, right? We have found that as well, right? So then we need to find the potential at D. If we could find the potential at D, we have the answer, right? Then, so we are assuming BE forward bias, the potential here, potential difference is 0.7 volt, and here potential is 0. Then current flows from B to E. So VB potential is greater than VE potential, right? Here the potential at B, of course you can see it's 0. So then the potential at E, it has to be, the difference is 0.7. So the potential difference, it has to be minus 0.7. So you should know that, right? So it's E minus 0.7 volt, right? From this actually we can find the current through here, IE current. We can assume IE is equal to IC, and that is also equal to ID current. It flows like this, right? Let's find IE current. So let's apply V equals IR here. V, potential difference across 9.3 kilo ohms resistor, is 10 minus 10 minus 0.7. I'll write it like that, minus 10 minus 0.7 volt into IR. So I'll write the values here now on this side. So minus 10 minus 0.7, it's 9.3. That equals I 9.3 kilos. So 9.3 into 10 to the power 3. So I'm getting I equals 9.3, that cancel off. So I'm getting 1 into 10 to the power minus 3. That means 1 milliampere. So current through this IE current is 1 milliamperes, and we can assume IC current also 1 milliampere. That means ID current through the drain, current through D and S, actually that is 1 milliamperes, current through the channel, right? 1 milliamperes. So to find the potential at D, of course, what we can do, we can apply V equals IR for this 8 kilo ohms resistor. Let's apply V equals IR for 8 kilo ohms. So 1 into 10 to the power minus 3, 1 milliampere. That into 8 into 10 to the power 3. 10 to the power minus 3 cancel off, we get 8 volts. So potential difference across this 8 kilo ohms is 8 volt. So here potential is 20, difference is 8. So potential at point D, we can assume it's 20 minus 8, 12 volt. So now we have the potential at D. VD is 12 volt, and of course we have VS 1.2 volt. Let's take the difference. That's 10.8 volt, and that is our answer. Students, I'm telling you, aim for these 3 marks. It's easier, it's very quick, and if you have practiced it really well, the accuracy is very high. Try the electronics 3 MCQs. We'll be getting 3 MCQs from Gates and from other parts actually. 3 questions, 3 marks, easy, quick marks. So try questions and you can get these 3 marks.